Well, hi, and thanks for joining me in my shop here for the second video on this amplifier. It's July 22nd, and I looked over the comments that were made on the first video. Thank you very much for making those comments. I could certainly benefit from help and experience of others with something like this. This is not the kind of thing I'm used to. Yes, it's just an amplifier, but for crying out loud, look at it. Holy smokes. So I knew from the start I'd have my hands full with this, and I need more hands. There's so much stuff here. So let's start with some things here I found out on my own by looking at the schematic and just getting a little more knowledgeable about this unit right here. So let me spin it around here. So first thing is, hey, what about these transistors down here, which I suspected were in some kind of special function of some sort. No. This is the front end amplifier for the signal coming in. So the signal's coming in through the connector, it's then going through these two transistors, and then heading its way to the first tube, which is this one here, not this. So why these transistors look different? Can you see they're different looking? I'm not sure. It's the same transistor, a 2N109. These two are General Electric. I don't know why these look different. Maybe there's a situation here where typically two of these need replacement and have been replaced. I would guess these are the newer ones. I don't know. I don't know the history behind it. So, but they are really the front end preamp to the preamp, I guess you could say. Why would they use these? Why not stick with tube technology? I don't know the answer to that. I can only guess. My guess is, because I know the cartridge is a low impedance cartridge, that this somehow enables a low impedance front end to the amplifier that you can't do with tubes. Now, is that true? I don't know. That's just a story. Now here's some good news. So there's these two tubes here. 6 BJ6s, two of them, one for each channel. One of these is dead. Did I say this? I've tube tested all these tubes before I did anything, so I know where the dead ones are. So I read that the purpose of these two tubes is not amplification, but in fact volume control. So jukeboxes have a special problem with volume control, and the problem is they are playing in a public location, or back in the day, playing in a public location like a restaurant, and there's no one with their hand on the volume control 24/7. In your home, your hand is on the volume control. Every time you go up to your stereo, and I guess we use remotes now, don't we? You've got a volume control right at your access. So what happens with the jukebox is the record volumes vary a lot. At least back then they did. The record makers are trying to put the strongest, loudest sound on their record, so it would play loud in your house and it would sound better. You put all those records into a jukebox and you encounter quiet ones and loud ones. And if you're not controlling the volume in the restaurant, you're going to have a problem, particularly if there's a blaster of a song that somebody picks. So the automatic volume control here is not about compressing the sound, really, and not about trimming off sudden peaks or anything like that. It's about lowering the average gain and keeping it there because the record you've put on is producing too much volume. So a little bit like a radio ADC, true enough. And of course, records have quiet spots and loud spots, and so there would be some breathing action on this thing where the automatic volume would go up and down a bit. So do you want that in your house? No, I don't think so. I don't think you want it in your house. So the beauty is, it says right in the instructions, if you don't want this feature, the automatic volume control, then you just pull these tubes out. They're out. Come on. There we go. And this is my replacement. Now, by the way, I've numbered every tube. This is number 8, not number B. This is number 1. I guess I went all the way up and then all the way up here. So they're all numbered, and we're going to take a look at the test results in a moment on the computer screen so you can see what the tube test results were. So what else have I learned? So there's a thing here called squelch and a thing here called mute. Mute, squelch, what's the difference here? Don't know why the word mute is here offhand, but up here is a mute control, mute switch. You can spring loaded for temporarily muting a channel out. And this is just applying a ground to the grid of a tube. I believe that's what this is doing. What this mute here I'm not exactly sure. J103 mute, maybe that's the name of the plug. Maybe it's the mute plug that operates the squelch control. And what squelch are you talking about? So the squelch is controlled from the record player. The squelch is on. Let's say it's stopping sound from coming out of here. It's squelching the sound whenever the needle is off the record, or close to that. So the idea is when the needle's off the record is being put back, things are happening, and there's rumbling, noise, stuff like that, dropping the needle on the record. Maybe that's even squelched out, so you don't hear the click plop of the needle hitting the record. So it's just to eliminate mechanical noise and all kinds of stuff that might occur between records. So the amplifier is shut down shortly after the needle comes off the record. That's my understanding of it. And that's what the squelch is. This test pin, we looked at this yesterday, and some pin voltages are here, which looks pretty helpful to me. But let's get to the trouble end here. Down at this end is all the hot stuff. The hot stuff. So we have 4 output tubes here, 2 driving tubes here, and in my case, you know what, maybe now's the time to look at the test results. Let's wait. I'll just finish my story here, then we'll look at the tube testing results. One of these tubes, actually put it right on it, short, exclamation mark. Well, exclamation mark. You don't want this tube in my tube tester. I don't want this tube in the set here when it's operating, because the short may be causing damage. I don't know. And now one of you kind viewers who took the time to put a fairly extensive comment on my first video and actually send it to me in email, thank you very much. I do pay attention to my email. I do not read all the comments all the time. In fact, seldom, frankly, to be absolutely frank. But for this, I think I will keep my eyes peeled on the comments. And if you should choose to send me an email, that's fine too. So the help is really appreciated with this. So what did I learn? So my comment is that it's typical for these tubes, these are 6973 output tubes, to develop a short, and for the short to take something out. And what the short can take out is a winding in one of these transformers. If that's occurred here, then we're in big trouble already. I don't know that that's occurred, but it's certainly an early thing to check, because if that's the state of affairs here, then the picture is dramatically different from what I hope. What I hope is that this guy is just tired and a little bit dilapidated, and not much more than that. I'm going to take these 2 tall tubes out, which I hope I am not mixing up. No, I'm not mixing up their positions, because I want to know where the shorted tube was. The shorted tube, let's just see if we can see any boomy stuff in here, any smoky, curled up, horrid stuff. So this is where the shorted tube was pulled from. Just looking at all the components attached, and I don't see anything that appears burned out. So the opposite can be true now. The defective tube taking out parts, defective parts can take out the tube. It's more likely the other way around, I think. And what defective part will we be talking about? We'd be talking about a failed capacitor, probably on the high voltage part of the tube. I don't think that's the case here. Usually when you have a capacitor go short, usually a resistor somewhere gives up the ghost too. Oh my god, there's a bug crawling around in there. Jeez. For crying out loud. Oh, there's a bug in the works. Okay, well. Oh, it's one of those ugly bugs. I hate those things. Well, he'll meet his demise off camera. I'm not gonna squish him for all you to see. So he's investigating just like us, in fact. In fact, that's my assistant in there. taking a close look at things. Well, in the comment there's some details about what capacitors really should be replaced, and the comment was all these blue ones are replacements. I'm not too surprised at that. And in my own mind, all the rest of them have to go that are either the paper type or this type. That's what's in my mind. This, all got to go. That's a lot of capacitors. Look, now that I'm looking at it more closely, it's even worse. These capacitors located in these boards. It's a lot of capacitors here, man. So my objective here is not to spend $1,000 of somebody else's money, replacing all these parts. My objective is to get this thing working good enough that you can rely on it for maybe a year or two or something like that. I mean, there's a bit of a magic wand there. you need to wave on that too. So let's take a look at the tube test results. I think what I'm going to try to do today is another piece of news here. Let me flip this guy over. Yes, a crane would be helpful at times in here. The cats don't do any heavy lifting. The darn things. No heavy lifting. So this terminal down here, okay, which the owner discovered that if you put 120 volts on these two, you can get the heater on this tube to light. The tube is sitting over here right now on my bench. It's just out on my bench. I think that's what he told me. 120 volts here. Good thing he didn't put 120 volts down here. That would have been the end of a few things. Down here you're supposed to be feeding in 6.3 volts for the rest of the heaters. So as usual, the rectifier is finding its voltage for heating, 5 volts for heating from the transformer. The transformer from which it is rectifying high voltage. So I had to hook up 120 volts here. That's easy. 6.3 volts with enough oomph to run 1, 2, 3, 4 and all these two tubes. 1, 2, 3, 4, 6, 10 tubes. So 10 tubes. Typical heater current 150. It might be 300 for these guys, because these are dual tubes. They have 2 heaters in there, probably each one drawing 150 milliamps. So let's take worst case, 300 milliamps per tube. Worst case, 10 times 300, 3,000, 3 amps. I gotta have a supply that can jam 3 amps into here. In the worst case, guess what? I have one. Just looking around my shop. Can you see this up here? So this supply is my high voltage supply that I can use to supply B+. B+, C- can come out of this too. And look, 6.3 volts, 4 amps out of these 2 terminals. So 4 amps now. Am I wrong about how much power is being drawn? I mean, I can always put a meter on it and be absolutely sure, so I don't draw 5 amps. These tube heaters might be, the heater current rating on them might be much higher than I think. 6973, let's find out. Where's that? 69, how does this book work? Does it have it in it? In the back here? Hey, where's the numbered tubes? That's not going to work. Okay, so I'm going to get my computer set up anyway, so the screen can come on the video, and we can look at the tube testing results, and I'll also find out the tube current demand and all that. Well, let's do that now. Okay, so here's the test results from the tubes from the set. I've numbered the tubes with the little green sticky notes. There's the numbers going down the side. And here's the tube identifier. And then this is the results with comments. So we'll just go down through them. There's 1, 2, 3, 4, 5, 6, 12 AX7s in there.
Now this in brackets is the expected result from the tube tester I was using. I was using my Stark 966, and it says for a 12 AX7, if it's 790 or less, you should throw it out. You should expect around 1250. So when we look at this, and there's a two-part tube, so I have two test results. These are the results. So you compare the results to what's in the bracket. I just didn't repeat what's in the bracket again and again and again down here. It's just on this one line. Okay, so this tube I would say is testing good. This tube, okay. This tube, no. This one tested low, and another sign of that is while I had the push button held down, making the test meter rise up to its reading of 500, if I held the button, I could see the meter going down. And I've noticed that in weak tubes, this is very common. So I tend to make a note about it if I see the pointer falling off the initial reading. So that guy's got to go. That's what this red is for. This guy's coming in 1250, 1250. That's great. This is like a new tube almost. This one here is coming in just kind of low, but it has that fall characteristic. So, and it's bold here by accident. I don't know why it's bold, but you see I've marked it as red. Need to be replaced. This 12X7 was completely dead. The heaters didn't heat on it. So there's two of these 6BJ6 tubes in there. These are the tubes that develop the automatic volume control control voltage, and these aren't really necessary. One of them was testing good and the other one was testing dead, but I do have a spare. So we can put, assuming my spare is good, which I don't know yet, we could potentially put both these back in and see what kind of AVC action happens in this thing way down the road. Now we get to the critical tubes. This is the 4 output tubes. So on my tube tester, the expected result is between 1260, throw it away, and 2000, be happy. And these are measuring 4,000. So that raises some questions about my tube test. This is unusually high compared to this number. That's typically not what happens. But in any case, I have two tubes testing identically. We can assume these are good. I think even though the 4,000 raises some questions, I'm pretty sure these are going to be good tubes. And the other two, no good. One of them has a short. It says on 3, my tube tester has a short control with 5 settings, and on setting number 3 a short shows up. We could figure out what kind of short that is if we wanted to, but at this point I haven't bothered. I just know there's a short on the tube. I do not want it in my tube tester, and I do not want it in this amplifier. That's the story there. This last one is totally dead. Probably the heater is not heating on it. I got a 0 reading on it on this guy. And good show, the 5U4 rectifier is actually very good. So that's the story. So when we look down here, we see 1, 2, 3 12AX7s. These are $20, $30 tubes, I think, on the internet. And I have these. I have replacements for these. I have a lot of 12AX7s, so I'm sure I'm going to find 3 good 12AX7s to replace them, so that's fine. The 6973 looks to me like there's no substitute. There's nothing you can do but get one of these tubes, and we will have to order it over the internet. I do not have any of these at all. So what can we do today? What can we do today with what we got here? Well, we got 2 good output tubes, and I think we have enough 12AX7s. I can scare up enough 12AX7s to get one channel going. So maybe this is a 1 channel at a time thing until some more 6973s show up. So the owner is facing a situation here, and as we'll talk a bit about it. Here's an item on my bench. It's already asking for $150 even before we really start. So that can be a little paralyzing. Now, jukeboxes are big machines. You got to expect to dump some significant money into them periodically, and so this looks like the second round on this amplifier. The first one, somebody put those blue capacitors in and whatnot. So you can see the dilemma. The $150, and there may be lots more to come. In particular, damaged output transformers. Let's go back to looking at the actual machine here, because that's what I did. Turned away from my computer screen and started looking at this.
So I think I've got enough tubes to run one channel. And then we can find out what's going on with the one channel we're checking. That would imply no tubes in the other channel. Why would I bother having any tubes in it? I think I've got just enough to kind of get one going anyway. So I would pull all the tubes out of one channel and then just do the other. Now, is there a problem with doing that? So for instance, the 6.3 heater voltage is based on the idea that there's 10 tubes sucking back power. If suddenly there's only 5 tubes, the 6.3 might become 6.5. I don't really know for sure, but maybe that's something we should keep an eye on. How bad can that really be? I don't think it can really be that bad. The output of a transformer is very low impedance. Variations in the load don't necessarily throw the output voltage up and down that great. It's a question of other components in the way between the transformer and the heater. There shouldn't be anything, like there shouldn't be a resistor in there. There should be nothing in the way. So you're just basically transformer to the heaters. You know, in an ordinary radio I wouldn't even hesitate, but this has got so many tubes I got to think about things a little bit. So another thing we can do is we can run this set with the rectifier out, so there's no high voltage in it, and that can get us through a certain number of things. Not too much really. I do have the ability to restrict and control the amount of power coming to the unit on the 120 volt side. The 6.3 volt side is just heaters. You know, there's nothing going on. But this side's busy with plate currents and all kinds of things happening. So, as for testing these transistors, you know, I can do it. I would end up using. I don't have a real transistor tester. Actually, I do. I have a vintage one, but I would never try it. So I got this guy. I could hook him up. Got the 3 leads. I could hook him up and get some, well, probably find out if one of these guys is dead completely. But for the moment, I really don't want to even touch them. I don't want to, they're in sockets. I don't want to pull them out, come in. I just don't want to do anything with them. Maybe everything is fine the way it is. These are germanium transistors. They're early. And my understanding is these were extremely popular transistors. 2N109. Interestingly enough, repeatedly while I searched for 2N109, the hits I was getting on Google involved Seeburg jukeboxes. So I don't know. It could be that most of the equipment that has these old transistors in it is long gone, but the jukeboxes are hanging on because they are so fantastic machines. People are hanging on to them and keeping them going. Okay, anything else I can talk about here before I really get into making a disaster of this? I can apply the 6.3 here and nothing more. I can put an ammeter on it. We can pull tubes, push tubes, and we can watch how much current's going in here and protect my little power supply up above. Another alternative I have is to actually hit this with DC. I have a very strong DC power supply. 3 amps is nothing to it, but I think I better stick with AC. Don't know why I'm saying that. If I study the schematic a bit more, I think I might find that that you could put DC in here without much risk. You know, I got these tubes out. It's out as it stands. Oh, more information. So if you look on my last video, you'll see a comment about 70 volt speaker systems, which I don't fully understand, so I'm not going to describe them other than to say you dare not hook up a regular speaker to here. That would not be a good idea. So you can read the comment on the last video if you're curious about that, and then do your own research. At this point, I don't think there's any reason why I need to go forward with this. The owner of this isn't doing anything with 70 volt speakers. I'm pretty sure of that. And this watt control, again, I don't fully comprehend what this is about. I have read it. I got to read it a couple more times to get it in my head, but I think it has a little bit to do with splitting the power between the 70 volt system and the regular in the jukebox speakers. I'm not sure. I talked my way all the way through? No, the last thing is, and this is a little bit upsetting. So, so here's the plug for the J102 remote volume control, and you see the plug is empty. I don't have the remote volume control, and that's probably the case with most jukeboxes. That was an option that the jukebox operator or owner could use in his establishment. But there was also a volume control stuck on the back of the jukebox, typically. Kind of out of reach of the customers or out of sight of the customers. And so the owner, operator, waitresses, whoever could run over, reach around behind and adjust the volume if need be. Where's that volume control here? It's not here. So there's probably a way to get around this lack of volume control, but the message I got in the comment on the video is no volume control, no volume. So I'll have to sort this out. So what am I really trying to do at this point? What am I really trying to do at this point? Is there some reason why I should heat up all these tubes? What's that going to prove to me? Get the situation ready for more thorough testing. I think that's really what I'm doing here today. So that does include putting the 6.3 here, measuring it, making sure I'm not overloading my little supply. Might include, I don't know what else. Let's start with that. Let's start with this right here. So I need a couple of clip leads. I'm going to try to keep the video rolling here today. So if it's a little stumbly at times, I apologize. And I just dropped every clip lead I have onto the floor. So we're going to go in here, common. Let's go here. This is ungrounded, not grounded back to the power system. If I wanted to do that, it has a terminal right here to do it with. So bring these over. And there's no level control or anything on this. As soon as I hit the switch, it's going to be 6.3 volts here. Is there really 6.3 volts here? I've never used this before, or maybe only once before. So trying to be a little bit careful. I really need a voltmeter. Where'd my voltmeter go? Who's taking it? Well, we'll use this guy. First, is it really 6.3 volts coming out of that? It pretty much has to be. What else could it be? AC. Okay, this is on standby. On standby, it produces the voltage. 6.6. So I think probably it's expected to fall a little bit as you put load on it. It's probably not a well-regulated, literally a small transformer producing this. But that's close enough. I think that's close enough. So what we'll do, this is really simple now. Turn it off. Turn off the power supply. Now I know standby energizes these things too. So I want to read the current. Can I read it with this guy? Yeah, I can read it with that. Okay, lower plug. Let's look at this. 10 amps AC or DC. 10 amps. What was it? 10 amp fuse in there. So I think it's just common and 10 amps. I don't think it's any more complicated than that. Make sure I get this right. How do I make sure? Best I can. Here we go. So I got a few tubes in there, so as soon as I hit the power, we should see some current flowing. If this gets above 4, I have to take action. It takes time for things to heat up though. And we should see these tubes heat up. And if there's a short on the heater, there shouldn't be because I've tested all these, and the shorted tube is here. Okay, we're good. Here we go. Ain't nothing happening. Okay, so I probably don't have this done right. Milliamps. Well, maybe this should go in here. Somebody, you know, a guy should know how to work his meters, shouldn't he? Maybe I'll move this from common to here. That doesn't really make sense, does it? Why else would there be no current flowing? Well, I'm going to switch the power supply all the way to the on setting and just see if somehow that makes it go. Here we go. No, of course not. What that really does is it energizes the high voltage part of that power supply, which we don't need. So it's back on just 6.3. Okay, I'll try this. Is there an on-off switch on this? No. Or get a different meter, Jim. Get one you're more sure of. Okay. Current is off. I don't think anything, if this is wrong, I don't think anything bad can happen anyway. So let's try that. There's no current flowing into this thing. I got these pins backwards. Did I look at this upside down and what I think is up is down? Okay, voltage off. Let's look underneath. Well, the way to identify these from looking at it is two of them go straight to this fuse. Or one of them goes straight to the fuse. And that's the 120 volt one. So you can see the 120 volt, that's the lower one. I did have it backwards. Because I did look at it upside down. Son of a gun. That's how mistakes happen. Thank God I wasn't involved in the space program. I would never have made it. Never. Okay, so I need to energize the 6.3 here. The 120 goes down there. Now, why did I put 120 in here and see absolutely nothing? Well, you know, or 6.3. Could be there was something, but my meter is in the 20 amp meter. I don't know. Don't have the tube in. Maybe that's the reason. No tube. I don't know. Okay, so we'll put 6.3 into here. I think this is going to be a long process. In fact, what I'm actually thinking of doing is work a few days on this and set it aside for a few days and work on something else and go back and forth between two items. So, you know, if that doesn't confuse my brain a lot, I don't know what would. But I'm thinking of doing that because I think I'm going to want to hear from people watching what I'm doing with this. That's what I'm thinking about. Ready again. 10 amp. Let's put this back where I really think it should be. Like there. Here we go. Ready? Remember, 4, we shut it off. Oh, there's nothing again. There's just no way this should be plugged on. No. 0 amps. So I'm so unsure of myself with this meter, I'm not convinced. Don't get convinced too quick. What did I do? I must have taken, you know what, I bet you it's out in the garage. Look, I'm going to dash out to my garage, I'll be back. I'll be back in 10 seconds. Okay, I've got my more trusty meter here. I think it's going to show exactly the same thing. Nothing. Okay, power's off. Leave that there, leave that there. What I'm doing is this on these. Turn off my singing meter. Going on amps. Unfused. And see here they have a nice white line. Shows you there's no code. And pull that out of there. Put this on amps. 20 amps. Something dumb here. Did I got this plugged in right? Yes, everything's right. Okay, we're gonna flip on the power supply once again. More than 4 amps. Nothing at all. Okay, this might go into the category of doing something really stupid. Now, is there some way there's a switch that's open on this? Uh-oh. So clearly, now, some of you who is watching this, may well know exactly what I should be doing here because you have experience. So you're probably shouting at me right now. I got anywhere. So you know what that's a possible sign of? I hate to say this, making the mistake I made but doing it with 120 volts. If somebody stuck 120 volts here instead of 630, all the tubes would pop. Tube heaters would pop almost instantly. That didn't happen. So the owner himself knows what he's doing enough to know not to do that. So I don't think that's happened. But why won't it get anywhere at all? I'm flipping this over so what was top is bottom. Learned that in grade 3. Okay, we can see clearly again 120 volts with the fuse. Or is that wrong? I don't think so. The owner put 120 volts through the fuse and saw the 5U4 heat. Oh, there's that stupid bug again. Okay, I'm getting them this time because I'm going to forget about them. Look away, everybody, while he's really hidden in there. He must have heard me because he's hidden himself in there. Okay, next time he shows, he's getting it. Well, let's just trace a few wires here and see if anything funny can be found. So off of here, I see 2 brown. Oh, okay. I think I see the problem. Yes, I do see the problem. Okay, so it's not top and bottom, it's left and right. Never even crossed my mind because somebody else showed me what they did. So now I can see these 2 on the short side are the high voltage and the 6.3 is on the long side. Okay, there we go. I'll bet you there's something in the manual I could have looked at. Would have showed that. So that was definitely a gambly thing I was doing without even really realizing it. On the long side. Power's off. Okay, once again, more than 4, got a problem, shut her down. Hot diggity, oh my gosh, look at that. More than 4 briefly is okay. Perfect. So this is behaving just exactly as we would want. It's also showing me that with 1, 2, 3, 4 tubes out, we're pulling 2 amps. I'm going to drop a little more. That's probably the end of the road right there. So we just take these and go 1, 2, 3, 4, 5, 6, 7, 8. 8 amps generating 4 8s. So that's averaging something like 300 milliamps a tube. And that might be just about right for all these tubes. Okay, it all adds up. So I think, yay! Round of applause. But wait, are any of these tubes actually heating? Oh yeah, you can see the heaters going on. So what if we load this thing up with tubes? Excluding the shorted tube, and might as well not put this dead one in. The dead one doesn't heat, so those two are out. But let's put these guys in. Just watch the current go up. So this is this is the other one. I think this is the dead one. So put this in. It may not jump the current. It may or may not. Yep, jump the current up. And oh well, the only thing I have out now is the 2 tubes I don't want to put in. So kind of what we're looking at is the maximum current drop, 2.5 amps. And if I put these in, surely to goodness it's only going to get up to 3 at the most. What that tells me is no matter how I arrange the tubes, I don't have to worry about my little power supply getting cooked up. Because I doubt it's fused or anything. Well, that's good. Let's turn it off now. Step number 61. What about the volume control? What about the speaker connections? Oh my gosh. I just feel like I've just taken the first step on a million-step journey here. Well, there's probably tricks around the volume control. Or there's probably a way I can make up a testy one to put in here. These volume controls can be complicated on these jukeboxes because they're designed to operate in a low noise kind of environment, if you like, because they could potentially be on a long wire. Yeah. We could go through the schematic too. Been doing this for half an hour now. Yeah, I think I'm going to leave it at that for today because it's another nice day. I may get down in here a little later if I get some better ideas in my head. I'm just a little unsure of what to try next. This volume thing is really stumping me. Yeah, so if I study the schematic, I'll learn how the volume control works, where it is in the circuit here, how far the circuit operates before the volume control steps in. And I should reread this watt thing here because I think it's really important to have this correct. And there's even a balance control in here which seems to be turned all the way one way. I'm not sure what that's all about either. So okay, so I'll read up a little more. And big step forward today. Thanks for watching. We'll see you on the next video.